Welcome to Subnetting Level 7, identifying the network and broadcast addresses. Let's begin by reviewing what we know about a Class C or /24 network. In this example, we are starting with the network defined as 192.168.50.0/24. The /24 subnet mask, written in its dotted decimal form, is 255.255.255.0. Recall that the subnet masks work with the IP address to determine which part of the address must remain constant to identify the network and which numbers in the IP address can be changed to assign unique IPs to different hosts on the network. In this /24 network mask, the first three octets in the subnet mask are defined by the network bits, or the 1 bits. That means that every host, such as a PC, in the network will have an IP address that begins with the three numbers 192.168.50. The fourth octet in the subnet mask is defined by the host bits, or the 0 bits. This means that the value in the fourth octet must be unique for each host in that network. Recall that the first IP in this range will be 192.168.50.0, and the last number in the range will be 192.168.50.255. The first and the last IP addresses in any network are reserved and cannot be assigned to a host device on the network. The first number in the IP range is called the network address. The last number in the IP range is called the broadcast address. In this example, neither the .0 nor the .255 number can be assigned to host devices, such as a PC or a printer. Instead, host devices should be assigned an IP address between .1 and .254. In the table, you will see the host address range is defined as 192.168.50.1 through 192.168.50.254. Sometimes a host IP is also called a valid IP or a usable IP. In this table, every IP address in the 192.168.50.0/24 network is listed. The network address and the broadcast address are in red text. Every other IP address in the chart is a host address. As we mentioned before, host addresses may also be called valid or usable addresses because these are the numbers we can assign to devices on the network. The network address is also called the network ID. With the subnet mask, the network address is used to identify all IP addresses in the subnet. The broadcast address is a special address that communicates with all hosts on the network. For now, just remember that you cannot assign these two IP addresses to devices on your network. Another very important detail to know about /24 networks is that there is a total of 256 IP addresses. Don't forget that we're starting with the number 0. Therefore, 0 through 255 is a total of 256 addresses. When we use the word total, that means we're including both the network and the broadcast addresses. The number of host addresses is 254. It is 254 because we have to subtract two numbers from the total to recognize that we cannot assign the network and the broadcast IPs to devices. You should memorize that a /24 has a total of 256 IPs and that the number of host IPs is 254. The table on the previous slide is helpful to illustrate every number in a /24 network. Another way I like to visualize a /24 is by constructing a subnetting wheel. I like to think of it as a pie. I might think of an apple pie, a blueberry pie, or even a pizza pie. Just like we slice a pie into smaller pieces, we can also slice a /24 network into smaller address ranges. The subnetting wheel or pie starts with the network number .0 at the top. Each IP address in the range is positioned around the wheel like numbers on a clock. At the quarter mark, we see the number .64. 1/4 of 256 is 64. At the halfway mark, we see the number 128. 1/2 of 256 is 128. We continue until we reach the last number, the broadcast number, of 255. Remember, there are a total of 256 IPs and 254 host IPs in a /24 network. From the previous video, we learned that there are subnetted network ranges in addition to the Class C and Class B IP address ranges. Each one of these subnets has a starting point and an ending point. The starting point, or the first IP in the range, is the network address. The ending point, or the last IP in the range, is the broadcast address. All IP addresses between the network and the broadcast IPs are valid, usable host IPs. Let's start by defining just the /25 IP address range. To provide some context as to what a /25 network is and why we would configure a /25 network, let's take a look at the scenario. Let's say you were a network administrator of a LAN that only needed 100 host IPs. We know that a /24 has 256 total IPs and 254 host IPs. So a /24 would give us way more IP addresses than we need. Our next option for a smaller subnet than /24 is a /25. A /25 network offers 128 total IPs and 126 host IPs, which would better accommodate this LAN. When a /24 is cut in half, the result is 2 /25 subnets. The first subnet starts at .0. The second subnet starts at 128. Why? Since a /24 has a total of 256 IPs, each /25 subnet would have half the number of IPs. So 256 divided by 2 is 128. Now that we know the network IDs of each of the subnets, .0 and .128, let's identify the broadcast address for each subnet. The broadcast number is the last IP address in the range. Therefore, the broadcast address for network .0 is .127. The broadcast address for network .128 is .255. Once the network and the broadcast addresses have been identified, all numbers between make up the range of host IPs. Let's call the first half LAN A. The network IP is 0, the broadcast IP is .127, and the host range is .1 through .126. Let's call the second half LAN B. The network IP is 128, the broadcast IP is 255, and the host range is .129 through .254. Here's another graphic that displays a /25 network. Given the network ID of 192.168.50.0/25, we see that the .0 number is the network, .127 is the broadcast, and the valid host range is from .1 through .126. Because the network ID ended in .0 and not 128, we conclude that this /25 subnet was referencing the first half of the IP addresses, or the first half of the pie. In this network diagram, we can see that we have two networks divided by a router. Each network has been assigned a /25 network. LAN A has the network ID of 172.30.1.0/25. LAN B has the network ID of 172.30.1.128. As you look at the PCs in each of the networks, notice how they have been assigned addresses in the correct subnet. LAN A PCs have unique IPs between .1 and .126. LAN B PCs have unique IPs between 129 and .254. So how does the router know which range belongs to which LAN? Great question. The router has two interfaces where a network cable will connect the router to other networking devices, such as switches. Each interface will be configured with an IP address. That IP address must be part of the valid host range. One common practice is to assign the router either the first host or the last host address in the range. In this example, we will assign LAN A's router interface the last host in LAN A subnet, 172.30.1.126. The dotted decimal subnet mask for a /25 is 255.255.255.128. Don't be confused by that subnet mask. In the next video, you will be introduced to a subnetting cheat sheet that will list all of the subnet masks for you. Next, we will assign LAN B's router interface the last host in LAN B subnet, 172.30.1.254. Again, the dotted decimal subnet mask for a /25 is 255.255.255.128. The IP address assigned to a router's interface is also known as the default gateway. The default gateway for a LAN A is 172.30.1.126. The default gateway for LAN B is 172.30.1.254. Regarding some clarification on terminology that's used in the curriculum and in this video series, a network may also be referred to as a LAN, a subnet, or a subnetwork. A subnet mask is not the same thing as a subnet. A subnet mask is a 32-bit number that specifies the network and host portions of an IP address. Examples include 255.255.255.0 or 255.255.255.128. The subnet mask can be represented using the slash notation, such as /24, /25, /26, and so on. Okay, so let's review. Let's see what you remember about the network and broadcast IP addresses. Pause the video, answer the questions, and then resume to review the answers. How many total IPs are in a /24 network? 256. How many host IPs are in a /24 network? 254. How many total IPs are in a /25 network? 128. True or false? Every subnet has a network IP address and a broadcast IP address. That's true. True or false? The broadcast IP is the first IP address in a subnet. That's false. It's the last IP address in the subnet. True or false? The network IP and the broadcast IP can be assigned to host devices. That is also false. These IPs cannot be assigned to hosts. True or false? The terms network address, network IP, and network ID all refer to the first IP addresses in the subnet. That is true. Those terms may be used interchangeably. Congratulations, you have completed level 7. Don't give up.